current inspection methodology was adopted from the previous contract company's schedules. It is obvious that there was very little strategy work or assessment of what was actually needed to ensure we maintain equipment properly. Inspections are of no value if we are getting no benefit from them, and inspections, which are basically pre-start inspections, are a waste of skilled labor. Open up our PM strategies and let's have a look at some of the inspections which are an obvious waste of resources. The first one we will look at is a monthly inspection on 7CEFF48 pumps. These pumps do not run for months at a time, and apart from doing a pre-start check, there is absolutely no value in monthly inspections. We have the run hours now for these pumps, so they can be inspected on run hours, not every month whether they run or not. These inspections alone utilize over 40 hours of skilled labor every month for very little return. Operators should be reporting faults on running equipment, not expecting the maintainers to do the pre-starts. Looking in MEX at our manually captured hours to date, we notice Pump 15 has done less than 100 hours work in 10 months. In this time, there have been 10 inspections carried out involving 2 trades personnel. There are many examples worse than this one, but inspection a pump every 10 hours of run operation is a gross waste of labor. Pump 14 has done a little over 400 hours in 12 months. Monthly inspections are pointless. We can move to an hours-based inspection with the future fleet data. The rest of these pumps have similar hour usage, so doing an inspection on all of them every month is not productive and achieves nothing of value. Another inspection to look at is the inspection of the critical 1420 pumps. These pumps are inspected monthly whether they run or not. In winter months, when running flat out, the fitters are completing 250 and 500-hour services every 2 weeks. In summer, most of the pumps do not run, so inspections are pointless. Pump 32 did around 1,500 hours in 12 months. This equates to 3 500-hour services, not 12 inspections and 3 services. Inspections should be scheduled by hours run. Pump 31 did around 300 hours in 12 months. These are just 2 examples of the 420 pumps. This PM is for an EEWP to be inspected every 4 weeks. The inspections rarely have anything to report, and apparently this unit is lucky to run 100 hours per annum. Installing a tracker and inspecting by hours is obviously a time saver. These are CF 7.1 pumps, and average usage per year is less than 500 hours, so 12 inspections is not productive. The same issue can be found with our inspections on forklifts and Manitous. Previously, I showed how we did 3 services on a forklift that had run only 50 hours for the year. Let's look at monthly inspections on our 50 or so gensets. We are attaching trackers to record and trip jobs automatically for service schedules. Genset 554 has run around 500 hours for the year. 12 inspections is overkill. This is the hours from Manitou 813. Less than 300 hours use for the year. Not worth 12 inspections. 1 service would need to be carried out. The inspections very rarely highlight issues. Another example, forklift 32 average around 250 hours per annum. Monthly inspections are no more than pre-start inspections. There are numerous examples of improvements to be made utilizing data from future fleet. Our fuel runs are done on a whim and with very little logic. Using tank sizes and fuel burn for equipment, we can automate the fueling schedule so we are not underutilizing the fuel techs. It is a simple exercise to upload the hours or kilometers from future fleet to MEX. Coding to determine fuel usage and plan proper fueling runs where we are not going to equipment that is full or adding 50 liters every time we do a fuel run. There is a lot of wasted time to be recovered in this exercise. As an example, the lighting towers have a 300-liter fuel tank. Fuel burn from the manufacturer is 1.5 liters per hour. If we set the refill alert at 100 hours, we can run for 133 hours between refills and still hold a reserve runtime of 67 hours as a backup. Looking at a few of the lighting towers that were refueled on this day, we average around 40 liters. It is not uncommon for the fuel tech to report the lighting towers are full of fuel. We are fueling these lighting towers at least 6 times too often and wasting time going to lighting towers that are still full. This example shows the fuel tech went to 8 bits of equipment that did not need any fuel. This is a very time-consuming exercise with minimal benefit to the client when other tasks could be undertaken. We need to create fuel runs dependent on need, not just drive to every bit of equipment and add minimal amounts of fuel. With fuel burn and tank sizes, we can automate the fuel run on a needs basis. After thoroughly investigating Newmont's future fleet asset tracking, it was found that over 90% of all trackers were wired incorrectly. Future fleet reporting was also incorrect since inception, as it was never set up or monitored correctly. We currently have repaired over 60 GPS units, which are now reporting correctly. Hours and kilometers run are ready to be uploaded to MEX to provide metering to the scheduling program. Jobs will be created automatically, no more 1 hour every day adding figures. No more missing hours for equipment for months at a time. Large productivity increases are expected from implementing this new process. Rapid data entry to our scheduling system. Less wasted inspections, which is a large portion of our work. More technical work and less pre-start type work, which adds no value. Fuel runs that are efficient, not just done for the sake of it. Fuel burn tracking on equipment to monitor equipment condition. The system has been in place for a long time. It has never worked correctly, and there was no link to a maintenance management system to utilize the data. This has now been rectified.